And before we proceed, I have to make a confession, right? So this is not the first time I ran SQL map against this task, because the first run is always really noisy and takes a lot of time. So this particular run, the first one, it took me around 15 minutes. Yeah, so it just the first time. Yeah, it's always better the second time, and the reason is that SQL map always stores the session for persistence, right? So it always has some previous checks and tests written down in a hidden directory against every target, and you have to flush sessions all the time when you want to do something from scratch. But in this particular case, it will save us some time for you not to watch how it just proceeds through logging its activities. Okay, so we will use, first of all, there is a separate section, yeah, in SQL injection category in utility, and it's SQL map practice. Here we will choose this task, view someone's block. It's somewhere here, right? It's always just a collection of different tasks in some category, right? There is like a meta wrapper for the tasks that can be resolved by a particular means of automation. So here we have some hints and videos for Burp Suite and SQL map. Why? Because we have to intercept traffic somehow. I will show you here in this video how to do that without Burp Suite, but then when we come in detail through Burp Suite, I will show how to do that more conveniently using like the set of tools, the integration of Burp Suite and SQL map in the same time. Okay, so we have this task, view someone's block. It's a simple web application that just takes a selected option from you, right? Or just shows you everything, right? So you can filter by an author. These are like log entries, right? So this is just a table in a relational database, presumably MySQL, of course, and it's made by some user. Yeah, so you have tables. You may assume at this point that there is some database there, okay? And there is not much choice you can make from the web interface, so we can consider that as a means of physical limitation of user actions, okay? But of course, we know that something is going on behind the scenes, and that's where we start digging deeper. We run an inspector, yeah, component of Google Chrome that allows you to see different technical information about the current session. Of course, Firefox has Firebug. It's an extension that is even more powerful, but Chrome just has it out of the box. Yeah, so why not using it? Let's just run this query again and see what happens. On the network tab, we can observe that multiple elements of the page are downloaded, right? So we have some JavaScript here, some CSS sheets, and the graphics, and of course we have some HTTP traffic. Yeah. So what is interesting to us here is just this request headers portion and form data that is passed. So from that we will take all the required information, and we will have to use, first of all, the URL, yeah, that's here. We will have to use cookie, okay, just to stay within the same session as this web browser, right? And we will have to provide data, of course, in a raw form like this, as it goes in the post section of the request. Okay, and basically that's it. Everything else will be configured from the command line. Okay, so when I ran SQL map against this URL, it looked like this. So the URL goes here, right? This is it. Then data is provided like this, right? You just copy and paste it from somewhere where you intercepted the data. Then I specify the parameter I want to try to SQL inject. This is author, because otherwise it will start from page and test it for injectability. Then it will go to author, of course, and then this view someone's blocks PHP submit button will also be tried for injectability. Then I provide cookie, yeah, to specify the session. Then I specify MySQL database management system just to skip all the other tests, yeah, that are available. And I specify level 5 and risk 3 just for fun. Okay. And I just want to see what is the current DB. So this last option, it gives an instruction to SQL map. When you are successful in injecting the parameter author, do something, yeah? So execute some payload and investigate what is the current database for the application. Okay, so this is how execution goes. Yeah, legal disclaimer, of course, do no evil, and then going line by line, you can review it on your own. I will just highlight some deliverables, yeah, that are here and actually are highlighted. So first of all, author might be injectable, yeah, so there are some signs of it in the early phases of execution. Then it even has an idea about accessibility of that parameter, yeah, so it's reflected to the page somehow, and this gives SQL map an idea that maybe there is a cross-site scripting as well, so it just shares this insight with us. Then we have that one technique triggered this result, yeah, so first successful guess is that there is a technique that is Boolean based blind with conjunction with where and having clause. So this is the full name of the technique, and yeah, it will be injectable by this technique most probably. But at this point, SQL map doesn't stop. It tries other techniques just in case there are some more simple or effective or efficient ways to inject the parameter. So it finds another one, error-based, yeah, where having order by a group by clause, and then it goes through other checks. It goes, and then it tests against union queries by different numbers of columns. Yeah, if you dig deeper into how SQL injection works, you will see that this is really like essential, just to see what are the limits of injectability, right? So how much data you can retrieve using a particular SQL injection. And yeah, this is the main takeaway in the first run. It's vulnerable. Do you want to test other parameters? No, I don't. Okay. And then it's just having my consent, yeah, for not going on any testing, it starts issuing payloads. And here we have this payload execution. So this is parameter, this is technique, blah, 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 all the technical information that is really boring. And here we have the final result. So I've asked for the current database and it's called NoWasp. Okay, and now just to show you the second time. Yeah, so the second time it ran, and just to see how much time it was running. So it ended at 11:37 and it started at 11:17. Yeah, 20 minutes. Okay, not a bad result actually. It's just one parameter and a really busy virtual box machine with not enough memory. So the second run is of course much faster. I just changed the payload specification for current user. Yeah, and see, I just configured that at root with root access, which you should not try at home. Yeah, so letting web applications to access backend databases with root user permissions in production is certainly not a good idea. Okay, but it's like default configuration of multi-relay. So here we are having two runs of SQL map against this particular web application, and now let's change the payload for something more interesting, like dump all. As we see, no testing is executed. It skips straight to the payload section, and it does everything that we do manually when we exploit SQL injection. So first we retrieve the information schema to see what are the databases, what are the table names, what are the column names, and so on. So the databases, of course, are MySQL, NoSQL, performance schema, information schema, and all the technical stuff, right? Information schema, performance schema are technical. MySQL is configuration technical, like it contains the users, the passwords, and all the other configurable information. You can access that directly. And NoSQL, of course, is the application database. It takes quite too long. Yeah, so you see it retrieves that. So maybe it's a good idea to just stop it here and specify the database. I want to quit. Yeah. So let's dump database NoWasp. So there are 13 tables in the database, and they namely are accounts, balloon tips, blocks table, capture data, credit cards. That might be interesting. So yeah, as you see, it takes some time too. So let's specify maybe only this credit cards table. Right? Yeah. So it starts enumerating the columns. CID integer, CC number text, CCV text, and the expiration date. Yeah. So as you can see, it starts retrieving the rows one by one. So number one is apparently a test number. CCV code is 745. Expiration date is somewhere in the 1st of March 2012. So something is going on on the background, right? So everything is pretty visual, and I think when it finishes retrieving, it will show us, yeah, the nice table, and it will dump to an output file as well, and CSV format for your convenience. Okay, so as you can see, that is pretty. It is a pretty neat tool that basically doesn't leave you any space for an error, right? So it's quite automated. It double checks itself. So let's demonstrate how a possible operating system compromise looks, yeah, using SQL map. So OS shell is the command, I guess, just to check whether it's possible. Most probably it is. So PHP is our choice here, just because we know that your application is written in PHP, right? So by default, we are using it. So the file stager is tried to be uploaded in using different techniques, right? So, oh, yeah. So that's not what was possible, yeah, by using a current operating system configuration. So most probably web application user in the operating system just doesn't own this directory. It can read, but it cannot write. Yeah, so I'm leaving this for your homework, right? You totally can do that. Yeah, you can upload a web shell by an SQL injection in MySQL. Yeah, configured by default. However, you have to have some more realistic configuration, because I certainly copied this directory structure as root user in the operating system, and the web application is then read from those PHP files and executed in memory as Apache user. So naturally, Apache user doesn't have writing permission to this directory. Which is not what usually happens in production. Yeah, normally Apache user just has total access to its home directory, and that's what should and is normally exploited during the penetration test. So now let me show you another cool feature of SQL map, that -r option. Yeah, so instead of writing all this long and complicated 3-line shell commands, yeah, you can do that in an easier way. So just taking this raw source of request headers, right, with all the cookie information here, right, and all the URL path in the beginning of this section, we can just cat it to a request file, right? Then, oh, come on. Then skip one line, yeah, because the post body and the request headers in an HTTP request should be divided by an empty line, and then put the post data here. Okay, so this is our request. If we send it to the web application, most probably we will get an equivalent of this response we see in the browser window right now, right? So this is why we intercept the traffic. And now we just SQL map with -r and this request file, and do the same stuff. Select the database that is of course no WASP, and do the dump, and select the table, of course, for credit cards, and do the dump. Okay, so everything is cached. Let's do something slightly differently. What is the other table that may be of interest in this database? Accounts, I remember, right? So let's just take this accounts. Table and try to dump it as well. You see? You can skip all that pesky configuration. You can make mistakes in altogether just by creating a file that configures the session fully, and by the way, gives some more information to SQL map to use while initially testing the web application for the injectability of certain parameters. So it is totally required when we are dealing with web services, just because everything is post there. Get data normally is not circulating between the server side and the client side, just because, yeah, there is some at least level, some minimum level of confidentiality to preserve, and that's why even if it's totally RESTful and you have all the methods specified and even some values for parameters specified in the get URL string, you still have some sensitive data passed through post bodies, right? So it's not really easy to put all that JSON mess, right? Because the constructions of post bodies in web services can be really, really large, and they use a lot of special characters that are treated differently in the bash command line interpreter, for example. So you will definitely have to put that into some kind of text file, and then please be wary that it's always important to specify the specific parameter. Yeah, so the parameters should be explicitly defined anyway, because otherwise, if you have these request bodies, there will be so many parameters that running SQL map against all of them is not practical. So you will have to work out of some intuition, maybe after some time working with web applications and the SQL injections specifically. You will see the perspective in different parameters and maybe skip some of them altogether. So as we see, accounts is maybe even more interesting because it has usernames, passwords, the signatures for the posts, right? Hank is my dad, this is funny. And the password is Bobby. Okay, so yeah, maybe we should have started from this one because it takes quite some time. Let's just check in the web interface how many of them are there. Yeah, so somewhere in the end is a baker and add, and now we are at number 10, and there are around of twice and a half as much of them. Okay, so maybe we should wrap it up with the SQL map at this point. Alright, so you get the idea. In the end, we will have this nicely looking table that represents all the data retrieved from this particular database table, right, with all the users and passwords and some meta information about them. Okay, so now let's go see what Burp Suite is.